Alright guys, welcome to the last problem of Chapter 6, Exam 2 Review. This is going to be Chapter 6, number 10. We have a pin at A and a roller at E. We have 12.5 kilonewtons at A, B, C, and D. They are asking us to find the force in member BC, FC, and FG. So Jackson is going to give you a problem very similar to something like this, or any type of truss system that is going to ask you for 3 members at a time. That way you can do method of joints and or method of sections, so you have the option. So drawing our free body diagram, we have our force in the AX and AY, and we have our force EX. We have our 12 kilonewtons at A, B, C, and D. So now we need to know if we can take method of sections. So we're going to do some cuts, see which one works best for us. So we're looking for force member BC, FC, and FG. So if I took a cut right here at cut 1, I could do that, but I'm not going to find my force BC, FC, and FG very easily. But if I take my cut at cut 2, I cut right through the center of the beams that I'm having of interest of. Now I can find them in one shot. Now the choice is, do I want to take all my analysis from the left or all my analysis from the right? You choose the one that's going to be easiest for you using method of sections. We are going to look at this problem from the right. So let's go ahead and do our sum of forces of the entire system. Get those out of our way. We have AX plus EX is equal to 0. Sum of forces in the Y is equal to 0. Positive in the up direction. AY. I'm going to combine all of those 12 kilonewton forces as it to be a total, moving it over to the right hand side as well, 50 kilonewtons. But now I have AX and EX that I don't know for, so I need to take a moment. So in the moments, I'm going to take it about A equal to 0. It's going to be positive in the counterclockwise direction. We have EX times 2.5 meters minus 12.5 kilonewtons times 2 meters minus 12.5 kilonewtons times 4 meters minus 12.5 kilonewtons times 6 meters, all equal to 0. Simplifying now and solving for EX, we get EX to be a positive 60 kilonewtons. Now we know EX, we can find AX. AX is going to be a negative 60 kilonewtons. Okay, now we can do our method of sections. So section at cut 2 is where I'm going to label it as, so that way we know where we're going. And I'm going to go ahead and redraw the new part of our system. We have our force in member BC. We have force in this member FG. And this force member FC. This is point C, point G, point D. We have a 12.5 kilonewton force at C and a 12.5 kilonewton force at D. From the dimensions in the problem, this is 2 meters, and now we need to go ahead and find what this length CG is. To find length CG, all you need to do is Pythagorean theorem and solve for that length. We get our length CG is 0.833 meters. Feel free to pause the video and double check the math to make sure you know how to get that. And we will continue on. So now we know that, we can start taking our sum of forces in the moments. Sum of forces in the x are equal to 0, positive x direction. We get negative force BC minus force Fc sine of, now I'm going to put this as beta. Now I'm labeling my beta, go back over here, I'm labeling this angle right here as alpha, this angle right here is beta, and this angle from the horizontal as theta. I will show you what those values mean in just 1 second. I'm going to go ahead and finish out this equation. Force EG cosine, is it EG? No, FG. My apologies, I wrote it wrong. FG cosine of theta is equal to 0. To find those angles, theta is equal to inverse cosine of 2 over 2.166. Now that 2.166 is coming from, on this part of the triangle, this one right here is 0.833. I do that by solving 2.5 over 1/3. So this one is going to be 2.5 divided by 2/3 to get 1.66. Yeah, so I actually have a typo right here. I'm going to readjust that. I'm going to start this off at alpha actually. So alpha, my apologies guys, alpha is going to be inverse tangent of 1.667 over 2, which is 39.8 degrees. Define our beta, it's going to be 90 minus 39.8. We get that to be 50.2 degrees. Okay. Going back to our equations, sum of force in the y is equal to 0. We get a negative 25 kilonewtons. I'm just combining the 12.5 kilonewtons into one force. That way, because it's just sum of forces. Minus force Fc cosine of beta minus force Fg sine theta is equal to 0. Now, I've got too many unknowns, so I need to take a sum of, not forces again, but moments. I'm going to take a forces moments about F. Now, I know that I made my cut and you can't see F in this problem. F is somewhere outside over here. I can still take a moment about those even though it's not part of my cut. So doing that, we get force BC times 1.667 minus 12.5 kilonewtons times 2 meters minus 12.5 kilonewtons times 4 meters, all equal to 0. Now I can solve for force BC. Force BC is 45 kilonewtons. But I still have too many, I have 2 unknowns and 2 equations. So the easiest way to do that is going to be solving them into a matrix. We get force Fc sine of 50.21 degrees, force Fg cosine of 22.62 degrees. Now, you're going to be asking me where you're getting this theta, you know? So, to find theta is going to be to what I was going to do, actually trying to do earlier, which is inverse cosine of 2 over 2.166. Double checking that math. 2 over 2.166 is 22.62. I'm a little off. That's probably because I'm in the wrong mode, but just watch out for your calculator mode. Make sure you're in degrees, not in radians for this section. That way you get your numbers right. So theta is 22.62 degrees. Okay. Continuing on, we get force Fc cosine of 50.21 degrees and force Fg to be sine 22.62 degrees inversed by negative 45 kilonewtons and negative 25 kilonewtons, all equal to our zero matrix. If you get any kind of confused or stumped on this, feel free to take a pause on this video, go back to my video over my TA84 how to input a matrix in. It's going to be the exact same format. All you're doing is inputting in your sine and cosine values in on your first matrix, and then your 45 and 25 in the second matrix. All it is a 2x2 by 2x1. Solving the matrix, we get force Fc and force Fg to equal negative 19.53 kilonewtons compression and negative 32.48 kilonewtons compression as well. Okay, and that is it. If you were attending the live SI session that we hosted, you probably missed out on a little bit. We had a little bit more deeper explanation than these videos. So my best tip is, if you can, please try to make the live sessions. I can actually see you in person, talk to you in person, and we can have better communication so I can help better explain things. While I'm on this computer doing these videos, there's only so much I can remember or write down to explain in these videos. So if you have any other questions, please feel free to shoot me an email or a text. And that concludes our Chapter 6 review and our entire Exam 2 review for Statics Exam 2. Again, if you have any questions, feel free to shoot me an email, send me a text, and I'll be more than happy to help. Other than that, good luck everyone, and hope they all do very well. Thanks.